Good evening, boys and girls. Today you should have learned Chapter 11 from Mr. Yu. And if I still remember, you should have learned about Chapter 11.1 and a part of Chapter 11.2 about Cyclic Quadrilateral. So in today's clip, I would like to go through the Cyclic Quadrilateral also for consolidation, okay, because some of you may not, okay, be able to learn completely from Mr. Yu today. So I think I have to give you more concepts about Cyclic Quadrilateral. But before I start talking about the Chapter 11, the Cyclic Quadrilateral, I would like to go through the last classwork, the Ch.10 Summary classwork, to highlight some of the important points that I want you to remember. First of all, I post the answer of this one, okay, today in the Google Classroom, so you may take a look to see, okay, whether you have done the work like me. And do remember is that, as I mentioned, when we want to do about the questions about finding angles or finding the unknowns, for example the length of course or the lengths of angles in using circle, you actually don't need to write the reference, okay, of your step. That means that you don't need to write the words like line joint center or angle center, even no. But what you need to present completely is that you have to write what you have and then you write what you want. For example, you can see like the question 5 here. So what I want to have or what I want to show is that I want to have perpendicular and bisect. So what I want to present our step is that I want to make, for example here, you can see the question 5 here, I want to use converse of Fourier theorem to show perpendicular. And also, since the bisect condition, that means that the two lengths equal are given from the question, so you can just write what you have for some of these two things, then you can get the implication that your answer, which we know AD should be the diameter of the circle. Actually, this one is the theorem 3 of your book in Chapter 10. I can't remember the words of the reference, but just this one should be the theorem 3. But actually, you don't need to say, oh, this is by theorem 3, or you don't need to write this so long words here. Because in DSC, what we want is that you just write what you have, and then you write what you want. So the yellow one would be what you have, and the red one is what you want. So this is the format of presentation. So keep in mind, okay? No matter for AE class or BCD class, all the classes should have the same format, okay, in DSC. So write in this way, okay? It's much convenient, and also you don't need to remember so long words to talk about, okay? Actually, okay, there will be some of the question, even the question 29, the most difficult question, I think, okay? And also, if you still remember for the question 29, I've already taken a clip, okay, talking about question 29, so you may go through again to understand what, okay, I've told to you. Then you can easily get what I've written here as the solution. Actually, you can see for the question 29, you don't need to write so long step. So after the first 3 steps, that means that you let x and then you write which one are x and x minus 18, then you can jump directly to say semicircle. Because the 3 arcs add together should be the semicircle AB, then you can get these 3 angles add together should be 90. Because these 3 are all angles at circumference and together is half circle or semicircle, so you have 90 degrees. Just like angle in semicircle, but this time, as I mentioned, I can say this one is the angles in the semicircle. That means that not only one angle, but there will be more angles together to be 90 degrees. So you can actually write in this way, but just remember you should write in this way, or otherwise you may need to add some line. For example, in this question, I add AC, and then to use some properties like the angle in semicircle, and then to combine some of the things here. But just remember, the most important thing is that no matter you use which method to present your question 29, all the idea is that they are actually all using the concepts of the arc corresponding or subtend to the angle at center or the angle at circumference. Just like when we go back to the question 9. So this question, okay, I could see some of you may write so long steps. Some of you may use angles of triangle, angles of polygon, or adjacent angles of line. But actually, you don't need to write so, because you can see I just use 3 steps, then you can complete the answer. And also you can see I write in black color to say you can also interpret this question like this way. So what does it mean? So now I would like you to take a look to the question 9 again. Then you can see the question 9 would be something like this. For example, now you have to find x. So if you still remember what I have mentioned is that if I say arc and angle have the corresponding relation, that means that, for example, this question, so I make it bigger to let you see clearly. For example, in this picture here, now if I say that the arc CD, then this arc can actually correspond to the angle 18 degrees in the figure, because the 18 degrees in this figure is called angle CBD. So you should know it should come from the arc CD. So we can just say the CD is corresponding to 18 here. On the other hand, then you can see this, you can have the 42 degrees here, you have an angle here. So if you still remember what I said in More to Learn, then you should understand that this 42 degree should be the difference between the two arcs, which is the arc AB, this one, as well as the arc CD. That means that what I can interpret is that the difference, which is AB is longer, so it means that AB arc subtract CD arc is corresponding to the 42 degrees. And also we know the arc CD is corresponding to 18 degrees. That means that in my mind, I should know arc AB should be corresponding to the 60 degree, which you can easily show here by using exterior angle triangle also. That means that actually, even you don't use exterior angle triangle, you have this idea that I can say all the angles corresponding to the arc AB. For example, this one, A dot boy, or also AC boy should also be 60, because it just comes from adding together. So even you don't look at the picture, you can understand this fact. But actually, you can also use what? You can use exterior angle triangle, because you can also see that you can take this triangle, then you can also have 60 degrees here. So once you have got this one, then if you still remember that this x, okay, this x is what? This x should be corresponding to the arc AB at CD. Because if you still remember, if you have two chords and the angle is between the two chords inside the circle, then this angle should have the measure related to the average of the one of the arc on the left and right. That means that this x should be corresponding to A boy at CD. In other words, if I say A boy is corresponding 60, C dot is corresponding to 18, x should be 16 plus 18. Plus 18, that means that 78, which is the answer. But actually, once again, this one you can easily get the fact that why you have such a result, because you may also use the exterior angle triangle again. Then you can also get x here. But just I would like you to understand is that even you don't use exterior angle triangle, you can just use the concept I mentioned before, is the relation between arc and angle. Then you can also get this answer very, very quickly. Just use this concept to do the question 29. You may also feel more easier to get your answer. Okay, so this is what I want to bring to you when I want to go through the summary classwork of the chapter 10. So for the other questions, just like question 31, 34, I think that you can read by yourself. But just also remember a skill is that this one. If I have the two chords equal, then you have the corresponding arcs equal. But sometimes the arc may be overlapped. For example, in this question, PRQ is the overlapped region between two arcs. For example, one is here, another is here. So this middle part should be overlapped. Then you can just take this part out to compare the separate part. And also the two separate arcs should have the angles corresponding. So you can just say the arcs separated are equal, then the angles towards the center will be also equal. So why I want to use this skill is that, so this one would imply you have this relation. That means that you have two separate x, which is one you want to find. Then after you have got 2x and other in terms of x, then you can do around the circle. For example, this one I use angle at the point, which is at center, then you can get the angle quickly. Okay, so this is what I want to bring about the summary of the chapter 10. So if you have no problem, then today I would like to give you a very easy concept first about the chapter 11, which is called the Cyclic Quadrilateral. So I would like to say that Mr. Yu told you the chapter 11.1 and 2 together today. But in this clip, okay, for easier understanding, I would just like to go through the chapter 11.1 only, okay, in this clip. So this clip, okay, actually is quite important. As I mentioned, okay, the chapter 11.1, okay, the first section of this chapter is actually very, very common that you can see in DSE. Okay, and also you have to understand the concept of the word cyclic quadrilateral. And do remember is that you can see in this chapter, many chapters you have the scissors here. That means that they are long foundation. But exceptionally, you can see the first one is foundation. That means that this one, okay, also appear in session 8. That means that it's very important. So don't miss it. So now go to take a look to see what's the meaning of cyclic quadrilateral. Cyclic quadrilateral, okay, in Chinese is called 原來接四邊形. So what is the meaning of 原來接四邊形 cyclic quadrilateral? Actually, you can see from the book. It is very easy concept. It means that if you have a circle, so I want to mention you have only one circle first, one circle. And on this circle, you have 4 points lying on the circle. Then you have 4 points, then actually these 4 points can be joined by using lines. Then you can form a quadrilateral. That means that you can form 4-side polygon, just like this one. Then we will call this polygon the cyclic quadrilateral. So it's just very easy. That means that all the 4 points must lie on the circle, Then you can form a quadrilateral. Then this quadrilateral is called cyclic. So actually the word cyclic, C-Y-C-L-I-C, means they fall on the same circle. So we call cyclic quadrilateral. So actually for the cyclic quadrilateral, there is a very, very important property that you use very, very commonly in DSC, which is called the opposite angles of cyclic quadrilateral. Actually, once again, this reason you don't need to remember. That means that the words opposite angle cyclic quadrilateral, actually you don't need to remember. But actually, this one can be also be explained by using the fact I just mentioned. So what is meant of opposite angle cyclic quadrilateral? It means that for every time when you draw a cyclic quadrilateral inside the circle, then the opposite angle between either two of them should be added together is 180. What does it mean? That means that now if I draw another circle, for example, I draw the circle this way, then I randomly mark 4 points. For example, 2 points are very near, and some of the points will be far away, just like this. Then you can actually draw, a quadrilateral. Then we will say that, for any angle inside, for example, I say this one, then you should have the one opposite, that means that it should be here. That means that not the next angle to the left, right, but will be next and next, which is opposite together. Then we will say that these two angles may not in same side. For example, I can say one is x and y. Do remember, x and y may not be equal. In general, they should not be equal also. But we can always say x and y added together is 180. So the proof of this one is actually very easy. Even you don't read the book, you can get the answer. Why? Because for example, in this question, why can I say the angle P and angle R added together is 180? Because you can just consider the arc, which divided by another 2 points, which are Q and S. So you can easily see that now, when I consider the left-hand side of the QS, for example, this one, then you can see it here, you have an arc here. But you know that this green arc is actually corresponding to the angle R. That means that, you can see that this one, is corresponding to the arc QPS, which is a QS on the left. So this one you have it corresponding to the R. On the other hand, you can see that the right hand side of the arc QS, which I using the red color here. So you can see this one, would have the corresponding angle towards the P. It's just like a symmetric relation, but actually they are not in the same side, so I cannot say really they are symmetric, but just one on the left and one on the right. So you will see that this one, you can have the relation of QRS and then corresponding to P. But you actually understand is that because QS, is divided by 2, one on left and one right, that means that actually these two together should become a whole circle. Just like the concept before, if the angles form the semicircle on the circumference, then we will have 190 degrees. That means that if the two angles from the two arcs which form the whole circle, that means the complete circle, so you should have 180. Because you know whole circle is 360 at center. So at circumference, because the angles are the circumference, so it should be 180. So it is a fact. It's just very similar to the angle semicircle, but what different is that this time we are considering the whole circle, the complete circle. So the angle should be 180. So why 180 comes? It's just very easy like this. And also I would like to say that in this session, so what you need to do is that you have to keep in mind this concept to use. Which angles can be 180 if they are opposite together in the cyclic quadrilateral. For example, in example 1 here, you can see here you have 5 points. But you understand is that for any cyclic quadrilateral, we have the opposite angle added together to 180. That means that here, the most important thing is that you have to understand what line you should consider when you find the situation. For example, here you have 5 points, so you can draw 5 lines as a pentagon. But pentagon is not what we want to know and what we are interested. But most important thing is that we can take any 4 points inside this figure. For example, this time I take A, I take C, I take D, and take E. Then you can see at this time the ACDE would give you this quadrilateral. And surely it should be cyclic. Why? Because ACDE, all these 4 points are line on the circle. So you know this one is cyclic quadrilateral. Then you can actually take the angles to compare. For example, I can take the 120, this one, with X. So they should be opposite. Okay, that means that in this session, what you need to learn and what you need to know is that in the figure, I have so many points, but actually we can just take any 4 points in the circle to form the cyclic quadrilateral. Then you can say the opposite angle is 180. For this question, you may have to take not only one cyclic quadrilateral, but you may have to take another cyclic quadrilateral. For example, here you can find X easily by taking this one. But here, if you want to find Y, which is this one, then you cannot take only ACDE, because you can see the angle Y is a part of the angle E only, but not the whole angle E. It means that we cannot just rely on this cyclic quadrilateral. But this time I may take another what? I may take another cyclic quadrilateral. For example, this time I take A, I take B, I take C, I take E. Then you can also form another cyclic quadrilateral, something like this. Then you can see this time if I consider this cyclic quadrilateral, then I can say this one is angle E exactly in this quadrilateral, not part of it. Each corresponding to the angle B, which is 130. Okay, in this problem. So you can actually see, we can have this one. So you can see the both would write in very, very detail to say, oh, in cyclic quadrilateral ACDE or in ABCE, you have the relation. But actually, you don't need to write so. You can just write the angle is 180 subtract which one. Then this is enough. Okay, just I mentioned before, because here you have already got from the figure that the cyclic quadrilateral. So what you need to do is you need to show me that your answer is 180 subtract which one. This is enough. Okay, this is enough. Even in your homework or in the test or exam or even in DSC. Okay, so this is the concept. Actually, okay, sometimes we have to combine the concept that we learned before. For example, isosceles triangle in example 2, as well as the angle in semicircle, which is diameter facing to 90 degrees. Okay, so just remember to combine all the concepts you learned. The second one is called the exterior angle of cyclic quadrilateral. So actually, exterior angle of quadrilateral is very easy concept. What does it mean? Actually, exterior angle of cyclic quadrilateral means that if we have drawn a cyclic quadrilateral, then we can make one of the sides longer, or we simply say produce one of the side towards to make another angle. For example, here it is the angle PQR. Okay, so this one originally is the angle PQR. So I produce the PQ longer to the right. So you can form another angle outside the cyclic quadrilateral, and we call this one is the exterior angle of the angle PQR. Then you understand the most important thing is that this PQR at X is 180 because by simply adjacent angle straight line. But you also know that Y at angle PQR is equal to 180 by cyclic quadrilateral. It means that these two at PQR are both equal to 180. That means that you will have X equals to Y. That means that for the exterior angle triangle, exterior angle cyclic quadrilateral, that actually means that, okay, we want to consider the angle next to the opposite angles only. Then you will know that this outside angle should be the same as the angle inside, because just you do 180 twice, then they will become the same. So this is also very easy fact that you, even I don't tell you, you will know. Okay, that means that sometimes you may also say the angle outside directly equal. That means that you don't need to write the reason, but you can just say, oh, they are just equal. Okay, from the fraction like this. So you can see that the book would not write so many steps and many examples to talk about the chapter 11.1, because actually chapter 11.1 is just an easy fact. So before I end this clip, I just want you to keep in mind a very important concept is that cyclic quadrilateral means all 4 points are lying within a circle. And why you have either two of the opposite angles add together is 180? Because the another 2 points other than these two angles would divide the circle into 2 parts, the whole circle into 2 parts, one corresponding to one angle, another part corresponding to another angle. So the whole circle add together is 180, so these two are also 180. If you take another pair, just like in the film 1 here, I take the 2 point angles, so you just fix another point. I take QS angle, then I fix PR. If I take angle P and R, I fix QS. Just very easy. Keep in mind this concept. So I think that this one, okay, you can read the example by own, and you can just read what you want to know, but because actually all the things are very similar, so you can see the book will just only show you for example, then finish this session. So I would like to leave the classwork to you. I don't know whether your subject teacher say you have to do my homework or you do Mr. Yu's homework or another homework. Just like what I said to the student is that, okay, in the second term, the marks will divide into 2 parts. One part is the homework that are assigned from subject teacher, not by me, but not by Mr. Yu, but from your subject teacher. Another marks would be the quizzes or the online exercise within the online lesson. Just like today, you have a quiz about fill in the blanks, talking about this session. So this one would count your mark, and the mark will be counted automatically by Google. Okay, because we use a Google form, so Google form will count the marks for us. Okay, but do remember is that whether you need to do my homework, do Mr. Yu homework, please listen to your subject teacher. So please follow the instruction from your subject teacher. Okay, so this one actually really for 4C. Okay, these 9 questions. Okay, so I will give you the 11.2 clip shortly. Okay, because Mr. Yu have already told you this one, so I will give you the clip maybe within Friday. Okay, but anyway, so just do this 9 questions, very easy. Once again, if you have any problem, please ask me. Goodbye and stay healthy.